Given question, design a DFA over the alphabet set A, B such that every string accepted must end with AB. So let's begin. We first define the language. Step 1 is to define the language. So this is my step 1. I start defining the language. The first string would be the smallest valid string over here. So the smallest valid string is string AB. Next, I can have, let's suppose A, B, ending with AB. I can have B, A, B. I can have A, B, B, A, B. Right? And so on. That is any combinations of A's and B but ending with AB. The language is infinite. Step 2 is to construct DFA. So we know the rules. First we have to construct the DFA for the smallest valid string. Next step is to complete the DFA. So let's proceed. From state Q0, which is the initial state, the smallest valid string in the language is AB. That is Q0 on input A will reach state Q1 and on input B will reach final state, because AB is a valid string in the language. Okay. Next step is to complete DFA, that is all the states has to respond to the inputs, pending inputs. Okay. Q0 has responded to input A. Q0 has to respond to input B. So at initial state, if I get an input B, how can I reach final state? I can reach final state from transition A, and from Q1 with input B transition, I reach final state. So is it a valid string? Yes, it is a valid string. So if I have n number of B's in the beginning, even if I have n number of B's in the beginning, I know that to reach final state, I have to come across this transition, that is transition A, input A and input B. Clear? So I say that I can put up a self loop of B over here. Fine. Q0 has responded to input A, it has responded to input B. Coming to Q1. To reach Q1 from the initial state, I have to come across the input A. Q1 has responded to input B. It has to respond to input A. On getting an input A, is it a valid string? Let's check. How can I reach final state from Q1? Only by having input B, I can reach final state. So even if I have n number of A's in between, okay, I know that to reach final state, I have to have this input or this transition, that is from Q1 to Q2. So can I put up a self loop of A on Q1? Yes, I can put up a self loop of A on Q1. Q1 has responded to input A, it has responded to input B. Now to reach Q2, I know I have to come across the basic string, that is A and B. If I get an E at Q2, is it allowed? No, it is not allowed, because I should be ending with AB. Right? So where the transition should be placed of A such that I will be getting a B at the end. So looking at the diagram over here, if I show this transition of input A on Q1, I know that I can reach back final state with input B, right? So even if I had only input A, B, A, let's check. Am I reaching final? Q0 on A reaches Q1. Next, Q1 on B goes to Q2. Q2 on A is now having a transition. Q2 on A goes to Q1. Right? Now it is stuck at state Q1. Am I reaching final? No. So this is an invalid state stuck in any of the non-final state. Correct? So this is working. Both for valid as well as invalid. Now, next input is Q2 on B. Now let's check. As we already know, to reach Q2 from initial state, I have to come across A and B. Right? If I get a B at Q2, is it allowed? It is not a valid state. It should not. It is not a valid string. It should not be reaching final. So I know I have to show up a transition of B such that there is a possibility that even if I get an A and then B, it should reach final state, because now this string becomes valid string since it is ending with AB. So where shall I put the transition of B at state Q2? So if I put up the transition of B at Q0, I know that I'll be getting an A and then a B to reach final state, right? Or if I had a string, let's suppose A, B, B, is it reaching final state? Let's check. Q0 on A will reach Q1, Q1 on B will reach Q2, Q2 on B will reach Q0, which is a non-final state. I am stuck at state Q0. So this is working for both invalid string and valid string. So the next step is to define Phi tuples of Dfa. We know that Dfa has Phi tuples Q, sigma, Q0, F and delta. Q is the set of finite state. So here in my given problem, I have states Q0, Q1 and Q2. Alpha sigma is the input alphabet set, that is A comma B. Q0 is the initial state. F is the finite set of finite states. Here I have only one finite state, that is Q2. And then transition function delta, which is given by Q cross sigma corresponds to Q. Next step, transition table. Define the transition table. It is given and it is, let's construct a transition table over here. I have inputs A and B, state Q1, Q0, Q1, Q2. Q0 is the initial state, Q2 is the final state. Q0 on A goes to Q1. Q0 on B, we have a self loop here, goes to Q0 itself. Coming over to Q1, Q1 on A goes to Q1. Q1 on B goes to Q2, which is final state. Q2 on A goes to Q1. Q2 on B goes to Q0. Final step, give an example, that is check your DFA for a valid and an invalid string. So first we'll check for a valid string. So we'll have a valid string, let's suppose A, B, AB. It is a valid string because it is ending with AB. So we'll check whether we are reaching final state at the end of this transition, that is at input for input B. So let's begin. Q0 on A will reach state Q1 on getting the input B. Q1 will reach state Q2. Which is final state. Next I have input A. Q2 on getting an input A. Where it is going, it is reaching Q1 which is non-final, and Q1 on getting input B. Getting input B, we are reaching final state, that is Q2. So at the end, I am reaching final state. So AB, valid string AB reaches final state. This shows the correctness of our DFA for the valid string. Next, let's check for an invalid string as well. Okay. So let's take an invalid string. Let's say A, B, B, A. Is it a valid string? No, it is not a valid string because here the string is ending with BA. Fine, so let's begin from initial state Q0. If I get an input A, Q0 on A goes to Q1. Next input is B. Q1 on B goes to state Q2. Next input is input B. Q2 on input B goes to state Q0. Q0, next input is A. Q0 on A goes to Q1. And Q1 is a non-final state. Right? So at the end of this entire transition, we are not reaching final state. That means this string is not accepted by the language. This indicates that this invalid string is not accepted by our DFA. This is how you should be designing up a DFA for the given problem, that is end with a substring AB. Given a question, design a DFA over the alphabet set 0, 1 such that every string accepted end with 1, 0. So we know the step. Step 1 is to define the language. Define the language. The language will contain all valid strings. So here in my language, what is the smallest valid string? The smallest valid string is 1, 0. Next combination can be 0, 1, 0, ending with 1, 0. I can have 1, 1, 0, ending with 1, 0. I can have 0, 1, 1, 0, and so on. So there are n number of possibilities, making sure that the string is ending with 1, 0. The language is infinite. Step 2 is to construct DFA. First step, I'll begin my construction for the smallest valid string. Right? So I begin my DFA construction for the smallest valid string, that is 1 0. Next step is to complete DFA by responding to all the inputs at every state. So let's start at state Q0, which is our initial state. I begin the DFA construction for the smallest valid string, which is 1 0. So I directly show the transition, that is from Q0 on input 1 I reach state Q1. From Q1 on input 0 I'll reach final state Q2. Fine. Next step is to complete the DFA. When I say complete the DFA, it means what? Every state has to respond to the inputs in the alphabet set. Okay, since it is deterministic finite automata, every state has to respond to the inputs. Now Q0 has already responded to input 1, right? At Q0, if I get a 0, right, what will happen? I know that to reach final state, I have to come across this transition, that is from Q0 to Q1 and from Q1 to Q2, 0. So even if at the beginning I am having n number of zeros, it doesn't matter, right? I know that to reach final state, I have this transition. So I put up a self loop of 0 over here. Clear? So now Q0 has responded to input 0 as well as 1. Moving forward to state Q1. To reach Q1, I have to come across the input 1. Right? To reach Q1 from the initial state, I have this transition with input 1. Right? Q1 has already responded to input 0. So if I get a 1 here, I know that to reach final state, I have this transition with input 0, right? So even if I have multiple ones in between, I know to reach final state, I have this 0, and this justifies my condition of ending with 1 0, right? So can I say I can have a self loop of 1? Yes, I can have a self loop of 1 over here. Right, for n number of ones is allowed because I am ending with 0 over here. Fine. Q1 is complete, it has responded to 0, it has responded to input 1. Next, coming to Q2. Now to reach Q2, from the initial state, we have a transition from Q0 to Q1, and from Q1 to Q2 with input 0, right? Now if at Q2, if I get a 0, is it allowed? It is not allowed. It is an invalid string, right? So what if after that I am getting a 1 and then a 0? Is it valid now? Yes, it is a valid string now. So where shall I place a transition of 0 at state Q2? Okay, where shall I place a transition of 0? If I place a transition of 0, input 0 at Q0, I know that to reach final, I have input 1 and input 0, which justifies my need. Clear? So Q2 for Q2 over the transition 0, over the input 0, I show up a transition to Q0. Next, Q2 has to respond to input 1. Once again, to reach Q2 from initial state, I have this transition with input 1, and from Q1 to Q2, transition with input 0. If at this place, if I get a 1, is it a valid string? No, it is not a valid string. right? What if I have a 0? If I get a 0 after this, is it valid? Yes, it is valid because it is ending with 1 0. So now where shall I place the transition of input 1 at state Q2? Where shall I place the transition 1 for state Q2? So looking at the construction, if I place the transition of 1 over here, right, if I place the transition of 1 over here, to reach back to final state, I know I have the transition of 0. So this justifies my case, right? Now Q2 has responded to both 0 and 1 and there are no pending states, right? So this completes our DFA construction for the given question. So now the next step is to define 5 tuples of DFA. We know that DFA is defined by 5 tuples: Q, sigma, Q0, F and delta. Q is a set of finite states. So here I have Q0, Q1 and Q2 as a set of states. Sigma is the input alphabet set that is 0, 1. Q0 is the initial state which is Q0. What about F? We have only one final state, that is Q2. And the transition function, which is Q cross sigma, corresponds to Q. Next step, step 4 is transition table. So construct the transition table. So here we know that we have to mention the input alphabet, that is 0 and 1, and the number of states. Fine. Here this is my initial state Q0 and Q2 is my final state. Let's begin. Q0 on 0 goes to Q0. Q0 on 1, Q1. Q1 on 0 goes to Q2, which is final state. Q1 on 1, Q1 on 1 is a self loop. Q2 on 0 goes to Q0. Q2 on 1 goes to Q1. Right? Next step, step 5, is to give an example. Next step, check for a valid and invalid string over here. So let's begin. Let's first consider a valid string. Let's suppose I have the string 1 0 1 0 0 1 0 1 0, right? So let's start. At state Q0, if I get a 0, I reach for this input. At state Q0, if I get a 0, I am in state Q0 itself. If Q0 for input 1, where am I going? Q0 for input 1 goes to state Q1, right? Q1 on input 0. Q1 on input 0 goes to Q2, which is a final state. Next, Q1 on Q2 on input 1. Q2 on input 1 goes to Q2 on input 1 goes to Q1. Right? Finally, Q1 on input 0. Q1 on input 0 goes to state Q2, which is a final state. So this is a valid string and it is reaching final state at the end. So this string is accepted by the DFA. Next, we'll check for an invalid string. Let's suppose this is my string over here. This is my string 0 1 1 1. So let's start. At Q0, if I get a 0, I am in state Q0 itself. If I get a 0, I am in Q0. Next input 1. Q0 for input 1 goes to Q1. Right? Next input is 1. Q1 on 1. It is a self loop now. It stays in Q1 itself. Next input 1. Same Q1 on input 1 is in Q1. So here the string is an invalid string. It is not present in the language, and therefore we can see that we are not reaching the final state. This is a non-final state. So our DFA machine is correct, right? So this is how you should be mentioning all the steps to get full marks in exam. Given a question, design a DFA over the alphabet set A, B such that every string accepted end with BAB. So let's begin a solution. First step is to define the language. The language will contain all possible valid strings. We begin with the smallest possible valid string. So here BAB is the smallest string possible. Next, I can have A, B, A, B, or B, B, A, B, or A, B, B, A, B, and so on. So language will contain all the strings that end with BAB. Fine. After defining our language, the next step is to construct the DFA. Now how do I proceed? I begin constructing the DFA for the smallest valid string. Right? Next step is to complete the DFA by responding to all the inputs at every state. Fine? So let's start. At state Q0, which is my initial state, I first begin constructing for the smallest valid string, that is BAB. So I directly show up the transition. This Q1 on input B, Q0 on input B goes to Q1. Q1 2 on input A goes to Q2, and Q2 on input B can reach final state, that is Q3. So this is the smallest valid string BAB reaching final state Q3. Next step is to complete DFA, that is every state has to respond to all the inputs in the alphabet set. Now Q0 has responded to input B, so it has to respond to input A now. At initial state, if I get an A, I know that I have this transition, that is input B, A, B. So if I have this transition, I am ending with BAB, which justifies my criteria. So even if I have n number of A's, I know that to reach final state, I have to come across these three transitions. So I put up a self loop of A over here, right? So Q0 has responded to input A, it has responded to input B. Coming to Q1. To reach Q1 from the initial state, I have the input B. Right? Q1 has already responded to input A, so it has to respond to input B. So if I get a B over here, How can I reach final? I can reach final only by getting this input A and input B, right? It is a valid string. So even if I have in between multiple B's, I know to reach final state I have this transitions A and B. So can I put up the self loop of input B on Q1? Yes. So here, even if I have multiple B's, I know I am ending I have the other two transition, that is transition A and input transition B, right? Q2 has Q1 has responded to input A and input B. Now let's complete state Q2. Q2, to reach Q2 from the initial state, I have this inputs, that is B and A. Q2 has already responded to input B, it has to respond to input A. Now if I have this string, is it a valid string? No, it is not a valid string. Can I make it valid? Yes, I can make it valid if I know at the end, if I get BAB. So where shall I put the transition of A such that even in future if I get BAB, it should reach final state. So from the diagram over here, I can find out that if I put the transition of A to Q1, I am getting this input B, A, B. Right? So this justifies my answer. Clear? Now Q2 has responded to both input A and input B. Coming to Q3. To reach Q3 from the initial state, I have transitions B, transition B, A and B. Q3 has to respond to both input A and B. Now let's check for input A. If I get an A, now this is an invalid string. It should not be there in the final state, right? So I know that the transition of A cannot be a self loop over here, right? But if I get a B after an A, is it valid? Yes, it is valid. So now I should be placing this transition of input A in such a way that even if at the end I am getting a B, I am reaching final. So I can see from the diagram that if I place up the transition of A over here, I know at the end I'll be getting B, right? Next, Q3 has to respond to input B. To reach Q3, I have inputs B, A, B. If I get a B, it is an invalid string, so the transition of B cannot be present at Q3. But how can I make this string a valid? I can make this string a valid if I encounter A and B. So I should be placing the transition of input B in such a way that if I come across A and B after that, I should reach the final state. So from the diagram I can say that if I put up the transition of B to Q1, I know at the end I can reach this A and B, right? So this is how we construct a DFA for the given question. Next step is to define Phi tuples of DFA. We know that DFA is defined by 5 tuples: Q, sigma, Q0, F and delta. Q is a set of finite states. So here in our case, we have states Q0, Q1, Q2 and Q3. Sigma is the input alphabet set, which is A and B. Q0 is the initial state. F is a set of final states, so here we have only one final state, which is Q3. And then the transition function, which is Q cross sigma gives Q. Right? Next step. Step 4 is to construct the transition table. Okay. So let's begin. For inputs A and B, number of states here are Q0, Q1, Q2 and Q3. Q0 is the initial state, Q3 is the final state, and this is my del function. Right? Q0 on A goes to Q0, Q0 on B goes to Q1, Q1 on A goes to Q2, Q1 on B goes to Q1, Q2 on A. Q2 on A we have a transition to Q0, Q2 on B goes to Q3, Q3 on A goes to Q2 and Q3 on B goes to Q1. Right? Step 4 is to Step 5 is to give an example, that is check for valid and invalid string. Okay, so we'll first check for a valid string whether a machine is correct. So let's take a valid string A, B, A, B. So this is a valid string. It should reach final state at the end of the input B. So let's begin. Q0 initial state, Q0 on A. Q0 on A goes to Q0. Next input B. Q0 on B goes to Q1. Next input A. Q1 on A. Q1 on A goes to Q2. Next input B. Q2 on B. Q2 on B goes to Q3, which is final state. Right? So at the end of the transition for input B, we are reaching final state. That is, this is a valid string which is accepted by our DFA machine. Next, we'll take an invalid input. Let's suppose I am taking B, B, A, A. Right? So let's start. Q0 on input B. Q0 on input B goes to Q1. Next input is B. Q1 on B. Q1 on B stays in Q1 itself. Next input A. Q1 on A. Q1 on A goes to Q2. Next input A. Q2 on A is in Q0. So at the end of this transition, am I reaching a final state? No, this is a non-final state. That means an invalid string is rejected by the machine and we are stuck in the non-final state. So this is how we can construct up a DFA for the given question, and this is how you should be writing the solution mentioning all the 5 steps to get full marks in the exam.